Hello everyone, welcome back to our learning channel, Learn with Jobs. And today we are going to discuss about something crucial in trigonometry, which is to find out the basic formula for trigonometric identities. So let's start. Here I have a right angle triangle. Okay, so consider I have now a right angle triangle. Okay, and I label it. This is triangle P Q R. Okay, and I have an angle which is angle QPR. So the angle is at P. Let's say this is angle alpha. Okay, now we know that QR is the opposite side of this angle. Let's say QR is equal to Y, and then PQ as the adjacent side of angle alpha is X, and the hypotenuse of this triangle, which is PR, is R. According to the Pythagoras theorem, we have that the hypotenuse, which is the longest side, can be defined by this formulation. R squared equals to X squared plus Y squared. Okay, now let's see the three basic trigonometric ratio. They are sine alpha, which is, remember, so ka toa, right? Sine opposite hypotenuse, cosinus adjacent hypotenuse, and tangent, which is opposite adjacent. Remember that. So it tells you the ratio of sine, cosine, and tangent, right? So sine alpha is actually y out of r. Cosine alpha is x over r. And tangent alpha is y over x. And then, bear in mind, these three basic trigonometric ratio has the reciprocal, such as cosecant alpha, which is 1 out of sine alpha. And then we have secant alpha, which is 1 over cosine alpha. And the last one but not the least is cotangent alpha, which is 1 over tangent alpha. So cosecant, secant, and cotangent, they are the reciprocal of sine, cosine, and tangent respectively. Okay, so you can find the value of cosecant alpha by using this formulation. Yeah, those are the basics that you need to remember and understand first before we go further to figure out another trigonometric identities formula. Okay, so that's the reciprocal of sine, cosine, and tangent. Next, I would like to take this. Yeah, the Pythagoras theorem, r square equals to x squared plus y squared. Okay, just keep it like this. Then I come back here. since sine alpha is y over r, so y is actually r sine alpha. And then for cos, yeah, we may know that x is actually r cos alpha. Okay, and then tangent, right? Okay, just keep it like that. Yeah, tangent alpha is y over x. Now we come one by one. Okay, so refer to the Pythagoras theorem. Then I substitute the value of y and x here. So x here, I substitute with this, so this become r cos alpha square, and y become r sine alpha square, yeah, outside of the bracket. So we simplify this, this become r square cosine square alpha plus r square times sine square alpha. Okay, now as you see here carefully, what we have, yeah, this is still r square. Okay, in this term we have r square, and this term also we have r square, so we can take it out and then put the bracket like this, and inside we have cosine alpha plus sine square alpha. Sorry, this is cosine square alpha. And then here to divide it becomes 1. So we have now is cosine square alpha plus sine square alpha is 1. So we have the first formula, right? This is one of the basic identity formula in trigonometry. Okay, hopefully you can get it, yeah? Then we continue further, yeah? So now I'm using red color. I take this. Tangent alpha is, okay, y over x. And the same thing, what I'm gonna do here is what? I just plug in y with r sine theta and x with r cosine theta. So tangent alpha is y is r sine alpha. This is r cosine alpha, and directly we can divide this, it becomes 1. So we obtain tangent alpha equals to sine alpha out of cosine alpha. Nah, can you see this? Okay, so we have this formula already. Okay, then the next thing, I'm using blue color now. Yeah, I take this formula, I put it here. So cosine, sorry. Okay, cosine square alpha plus sine square alpha equals to 1. Then I divide all with cosine square alpha. Please pay attention carefully. So we divide each term with this. So cosine square alpha divided by cosine square alpha, it will give us 1, right? And then this sine square alpha out of cosine square alpha equals to 1 over cosine square alpha. Okay, then, yeah, look at this carefully. I just take out the square, yeah, I put it outside. It doesn't matter, right? So this is sine alpha out of cos alpha. This is square, as well as this one. So 1 out of cos alpha square, right? So this is 1 plus, as you see, yeah, carefully what we have. Sine alpha, look at this, yeah, sine alpha, this one, okay, and then refer to the sine alpha out of cosine alpha equal to, sorry, yeah, look at this. Sine alpha out of cosine alpha is equal to tangent alpha. Very good. So this is can be written as tangent square alpha. And then this one. Look at this. Remember, 1 out of cos alpha, is it secant alpha, right? Secant is the reciprocal of cosine. So this one can be written as secant square alpha. So now we have another formulation, yeah, which is 1 plus tangent square alpha equals to secant square alpha. Wow, it looks amazing, right? Very good, isn't it? So mathematics is wonderful. Okay, this is our third formula. Then I still use this formula I put here. Ta-da! Okay, write it again. Cosine square alpha plus sine square alpha, which is 1. Now I divide all with sine square alpha. Sorry. Yeah, I need to make it good. Yes, like this. So this become cosine square alpha out of sine square alpha plus this is 1 directly. This is, this is 1 out of sine square alpha. Okay, now for this, okay, pay attention. Yeah, from the formula that we have, that tangent alpha is actually sine alpha out of cosine alpha. And meanwhile, cotangent alpha as the reciprocal of tangent, this is 1 out of tangent alpha. Then mathematically, by looking at this condition, we can write that actually cotangent alpha is cosine alpha out of sine alpha. Very good. Yeah. Now look at this. This is really, really amazing, right? Nah, okay. Look at this formula. Yeah. They are really beautiful. Okay. Then, now you see this part. Okay. 1 out of sine square alpha, remember? Yeah. This equals to, okay. Remember, 1 out of sine square, sorry, sine alpha is cosecant alpha. Okay. So that why the same thing I do like this one, like the blue one. Yeah. Okay, just right here below that I put bracket cosine alpha out of sine alpha, this is square, plus 1 equals to, in the bracket, 1 out of sine alpha, this is square. So this one is cotangent square alpha plus 1 equals to cosecant square alpha. See? They are really, really amazing. Right? Nah. Okay, let me try to fix the the box here. I'll make it better. Okay, so I'll just rewrite it again, yeah. Okay, that cotangent is cosine alpha out of sine alpha. Okay, so look at them. So beautiful, right? Nah, so we have this already. We have, yeah, look at that formula. They're awesome, right? Okay, that's the conclusion. We just write again what we have here. Okay, so what we have tangent alpha is sine alpha out of cosine alpha. Cotangent alpha is cosine alpha out of sine alpha. And then we have sine squared alpha plus cosine squared alpha equals to 1. And then 1 plus tangent square alpha equals to secant square alpha. And then cotangent square alpha plus 1 equals to cosecant square alpha. That's the formula. Yeah. And don't forget the reciprocal and the basic trigonometric idea. Okay. So, wow, look at this. So, normally, what you may, okay, what you may have here is the basic trigonometric identities formula that can be used, yeah, in dealing with any trigonometric identities problems. Yeah, we know that whenever we are dealing with trigonometric identities, it's all about proving. We prove, right? We prove the equality. We prove that the expression can be simplified and so on. Okay, so I think that's for today. I hope you enjoy, yeah, our discussion today, right? And hopefully they will be useful for you as part of your revision, or if you want to know how to get the formula actually. Yeah. Once again, thank you very much for your kind attention and see you next time. Bye-bye.